Hello everyone. So in this video, we are going to talk about separation processes. So let me introduce you to what separation processes are. Separation processes are the techniques used to divide a mixture into its individual components. It is essential in industries like food, water treatment, energy, oil refinery, and many more. So why are these separation processes important? Because it helps to create pure products by isolating useful materials, by removing impurities from the mixture. Therefore, it will improve the process efficiency and at the same time, it will reduce waste. So separation methods are chosen based on many parameters, and some of the parameters are boiling point, solubility, particle size, and density. So let us walk you through separation processes, especially in the impact of separation processes and also its use in the industry on the environment.
Next is economic impact on separation processes. Their economic impact can be evaluated in terms of operational cost, capital investment, and resource efficiency. First is operational cost, energy consumption. Processes like distillation are highly energy intensive. Improving energy efficiency can have substantial economic benefits. Labor cost. Automation in separation processes can reduce labor costs but requires an initial investment. Maintenance costs. Regular upkeep of equipment like filters or membranes impact operational budgets. Next is capital investment. Advanced separation technologies such as reverse osmosis require high upfront costs, making them economically challenging for small-scale operation. Modular and scalable design reduce initial costs, making technologies more accessible. Lastly, resource efficiency. Raw materials utilization. To save money, efficient separation minimize waste and optimize resource use. Byproduct recovery. Some separation processes enable the recovery and sale of byproduct, boosting profitability. Next is environmental impact on separation processes. Environmental impacts in separation processes can occur at various stages, from the raw material extraction to the disposal of waste byproducts. First is energy consumption. Separation processes such as distillation, filtration, or centrifugation can be energy intensive. For example, distillation requires high temperature, which may increase the carbon footprint of operations, particularly if the energy source is non-renewable. Next is chemical usage. Many separation methods rely on chemicals, which can generate harmful waste. Solvents used in liquid extraction, for example, can be toxic, and improper disposal can contaminate soil and water. Next is waste generation. The byproduct from separation processes such as spent solvents, solid waste, and air emissions may contribute to environmental pollution if not properly managed. The accumulation of waste in landfills or water bodies can lead to long-term ecological damage. Lastly, water use and pollution. Separation processes often require large volume of water for cooling, washing, or dissolving substances. This can contribute to water scarcity in some areas. Additionally, wastewater generated from separation processes may contain contaminants that can pollute local water resources.
And lastly, the impact of separation processes, which is social impacts. First, clean water for communities. Filtration and other separation methods provide safe and clean drinking water to the communities. These processes help prevent diseases and improve public health as well. Secondly, affordable food and products. Efficient separation process techniques reduce production costs, making food, medicine, and consumer products more affordable. As for examples, refining sugar, purifying cooking oils, and processing dairy products. And lastly, access to energy. Processes like distillation refine crude oil into fuels, and gas separation improve renewable energy system like hydrogen production. This will provide energy for homes and transportation, as well as supporting daily life and economic growth.
Humidification is used to control the moisture level in industrial processes. It involves adding water vapor to air in order to regulate humidity in environments. For the industry that apply humidification process is textile industry. The air humidification can increase productivity and product quality, especially the elasticity of the cotton and its tear resistance. Besides that, it can minimize the electrical discharge from the materials being processed, where it prevents damage to the sensitive materials. Maintaining appropriate humidity levels improves air quality and ensures a comfortable working environment. Next, the humidification in food and beverage industries can ensure quality and freshness of the products, especially when fruits and vegetables that are stored in cold and dry environment. Proper humidity can make the fruits and vegetables stay fresh and store longer. The third initiative is the cooling tower in chemical and petrochemical industries. It is an evaporative heat exchanger with a lower operating cost, where the heat is transferred from water to air, then the water will evaporate and cool down by latent heat of vaporizations, which then raises the air temperature and its relative humidity to 100%. Absorption is the process where a gas component is absorbed into a liquid phase, typically to remove the undesirable gases, recover valuable components, or control the emissions. The first initiative of absorption process is flue gas desulfurization. Flue gas containing sulfur dioxide enters through a scrubber system. Inside the system, the flue gas contacts with a slurry reagent through spray nozzles and agitators. The limestone reacts with sulfur dioxide in the presence of water to form calcium sulfide and carbon dioxide. This process aims to reduce the acid rain and improve air quality. Next, for the carbon capture, the amides and other solvents are commonly used to capture carbon dioxide from industrial emissions in order to mitigate climate change. Besides that, for the air pollution control, the acid gas scrubber controls emissions of oxidizing halogenated compounds such as sulfur dioxide, which may form acid gases during the oxidation process in a thermal oxidizer. And lastly, based on the water treatment plant, the absorption is widely used for removing contaminants from water, including heavy metal, volatile organic compounds, and dyes. Absorption can facilitate the oxidation complex organic compounds into less harmful substances.
So this is distillation. Distillation is a separation technique that based on boiling point difference of component in a liquid mixture. For example, producing pure water from dirty water. We usually use this distillation process in a large-scale separation in industry, for example, petroleum refining. So we are starting from crude oil, gasoline, kerosene, lubricating oils that based on. As for the applications for distillation process, we have water purifications and oil refining. As for the water purifications, it's used to purify the water by removing the impurities and like contaminants. So this method is particularly beneficial in areas with poor water quality, ensuring the water is safe for consumption and use. And for oil refining distillation, in oil refining, distillation separates the hydrocarbons in crude oil into distinct fractions based on their boiling points. So this process is essential for producing various petroleum products like gasoline, diesel, kerosene, and jet.
Now, I would like to talk about liquid extraction, or in short, LLE. The definition of LLE is that LLE is a separation process where a solute is transferred from one liquid phase to another immiscible liquid phase based on their difference in solubility. So the first application is pharmaceuticals, where LLE is extensively used in the pharmaceutical industry to extract and purify the active pharmaceutical ingredients, for in short, APIs. During the drug formulation, crude mixture from synthesis or natural sources often contain impurities. So LLE helps in isolating the desired compound by exploiting its solubility difference into immiscible liquids. And next is chemical processing. LLE is used to separate liquid-liquid mixture in the chemical industry, where simple distillation is very impractical, such as when a component have close boiling point or are heat sensitive. For example, recovering of acetic acid from a dilute aqueous solution using an organic solvent like ethyl acetate. Lastly is for food and beverages. LLE is utilized to isolate flavors, essential oils, and aromatic compounds from natural sources. These compounds are used in the production of food additives, perfume, and beverages. So this is about LLE. Next, we will talk about SLE, which is solid liquid extraction. Okay, next is for solid liquid extraction, or in short, SLE. The meaning of it also known as leaching, and it involves with separating components from a solid matrix by using a liquid solvent. The first example of their application is that extraction of copper oxide. This method which uses acidic solution, typically sulfur acid, so that the copper ion will be dissolved into the acid. And then the leachate, which is the solution that contains the copper, will be further processed by using a solvent extraction to obtain a pure copper. Next is for extraction of gold. This method uses cyanide instead of acid. This cyanide acts as a solvent that will dissolve gold particles from the gold ores. Then it will form a gold cyanide complex, which is soluble, and then the solution will be processed to recover the gold, the pure gold, using precipitation methods. And lastly, the brewing of the tea. By using this method, we use hot water as our solvent. This hot water will dissolve the soluble component from the tea leaves, which is caffeine or their flavor, to form a solution that dissolve solution. And then the insoluble component, which is the tea leaves, will be remain in the machine. So that is what we call this process as a solid liquid extraction.
The separation process play a significant role across various industries, impacting economic, environmental, and social aspects. So these processes are such as humidification, absorption, distillation, liquid extractions, and solid liquid extractions are essential for resource recovery, water treatment, air purifications, and pharmaceutical productions. All of them contribute to industrial efficiency, environmental sustainability, and the development of essential products. So the economic benefits of these processes are evident in cost reductions and resource optimizations, while their environmental impact varies based on how they are applied. Overall, the effective use of the separation process helps balance industry growth with environmental responsibility.